Welcome back to Old School Math. Today we're going to be taking a look at systems word problems, and I'm just going to give you this caveat. It's only a problem if you don't know how to do it. But thankfully with this video, you'll be able to take a word problem, make a system of equations, and then solve it. That's basically our I can statement for this video. I can make sense of word problems and solve them using systems of equations. So, a couple notes before we jump in. First thing you're going to want to do is read and annotate a problem carefully, right? There will be a lot of stuff in the problem that you will need to know, and there will be a lot of stuff that's just fluff, right? You're going to want to identify variables that you can use to solve the problem. Write down any assumptions and given information about the variables. We'll talk about that more in a couple of these problems. Create at least two equations that involve the variables, so that's your system, and identify any constraints that there might be on these variables. If you're selling products at a concession stand or something like that, you're not going to want to sell negative of anything, right? You actually can't sell negative of anything. So what you might want to look at there is saying, okay, X has got to be greater than 0, Y has got to be greater than 0, that kind of thing, right? You want to solve the system and then check your work for meaning, right? Interpret the values that you get for X and Y in context of the problem. Let's take a look at a simple one together. If you want to pause this video at any point and take things a little slower, feel free to do that. So if you've got your note-taking guide, this is on there, but unknown numbers. One number is 3 times another number. The sum of the two numbers is 36. What are the two numbers, right? So in this problem, I know a couple things. I know I've got two numbers. I could call those X and Y, right? Those are my two numbers, right? I don't know what they are, but what I do know about them is that if I take one of the numbers, is going to be multiplied by 3, and it's going to give me my second number, right? The other thing I know is that if we add these two numbers together, we get 36. So sum of the numbers is 36. So that would be X plus Y equals 36. Now I've got this system set up already. Didn't take me too long. Okay, what are the two numbers? So really I just want to solve this system for X and Y. They're not in the same form, so I don't want to use elimination. But one of them's already solved for a variable. This one's already solved for Y. So this makes me think substitution might be a good way to solve this. What I'm going to do is I'm going to take this Y value here, and I'm going to substitute 3X right there for Y. So I'm going to get X plus 3X is equal to 36. Okay? So if I do X plus 3X, that will give me 4X is equal to 36. We'll divide by 4, so X will give you 9. Now the next thing we want to do in our substitution of this stuff is pick an original equation, and we're going to substitute this into either one of the original equations, okay? So let's go ahead and substitute this into the top equation. Why not? 3 times our X value of 9 is equal to Y. Okay? So 3 times 9 is 27. So what this means is that our two numbers are 9 and 27. So X is 9, Y is 27. This doesn't have a lot of interpretation to it, but let's check it. Is one of the numbers 3 times another number? Well, yeah, 27 is 3 times more than 9. If we add these two numbers together, do we get 36? Yes, 27 plus 9 gives you 36. You solved this system of equations here. This next one's a little bit more in depth. It says you forgot your lunch money the last 2 weeks, and so you decided to charge your lunch costs to your account. Your parents get a bill from the school cafeteria for $28. Okay? So for 2 weeks, the total charge was $28. You ate lunch for 10 days. Okay? A standard school lunch costs $3.50, so I'm going to call this a standard school lunch, is $3.50, and a salad in the cafeteria is $2.50. How many standard lunches and how many salads did you charge over the last 2 weeks? So the first thing I want to do here is annotate, read carefully. Let's set up some variables. Let's let X be the number of standard lunches. And let's let Y be the number of salads. Okay? What else do we know about X and Y? Well, X costs us $3.50. and Y costs us $2.50. Okay? Now let's make a couple equations in terms of what we know about X and Y, right? The $28 piece tells us that we should work with these dollar amounts, right? If I said, okay, I'm just finding out how much money I spent on regular lunches, I would do $350 times X. And if I figured out how much I was spending on salads, that would be $250 times Y. But the total of these two has to add up to my total dollar amount there, which was $28. Okay? So we've worked with the dollar side of things. Let's just work with the pure amount side of things. I know I charge lunch for 10 days. And if I'm charging standard lunches and salads, there's going to be some combination of these two together, right? So we can say that's just X plus Y equals 10. Now, this might be one of those times where you stop, you scratch your head for a second and think, how am I going to solve this, right? Do I want to use elimination, substitution, or graphing? Truthfully, any of those three would work, but I'm going to go through this and just use, I want to use substitution. Students usually don't like substitution as well, so we'll do another practice with substitution. Let's solve this thing for X here, okay? We get X equals 10 minus Y. So we'll substitute that up here, the 10 minus Y. So we get 350. And in parentheses, we're going to put this 10 minus Y plus 2.50 Y equals 28. All right? Let's distribute this 350 inside here. So 350 times 10 would be $35. And 350 times negative Y would be minus 3.5 Y plus 2.5 Y. And I'm dropping the 0 to save a little space. And that's equal to 28. Okay? Let's combine like terms now. Negative 3.5 plus 2.5 is going to be negative Y. And 35 is going to be left over. We didn't touch it yet. Okay? Now, from this point, I want to, let's add our Y to both sides, make it positive. So 35 equals 28. And I said I was going to add Y over there, plus Y. We subtract 28. That leaves us with 7 equals Y. How's that? Well, if Y is 7, what's X have to be? Without even substituting this back in, just we know in our head, 3 plus 7 will give us 10, right? So that means that X has to be 3. So let's interpret this in terms of this problem. We said X is 3, that means I bought 3 standard lunches. And I ate 7 salads over the last 10 weeks. So when your parents are like, you charged all this money to the school cafeteria? Yeah, but mom and dad, I had 7 salads and I can prove to you that I was trying to be healthy here, right? I wasn't just buying junk food. Anyway, that's a nice little example there with lunch charges. There's one more with screen printing. Take a look at this one. Your club is looking to order club t-shirts and you're trying to figure out the most cost-effective company to use. Blue Label Screen Printing charges a design fee of $40 plus $6 per shirt. Extreme Graphics charges a $100 setup fee and $4 per shirt. How many shirts would you need to buy from each company for the cost to be the same? Now this is a little bit different problem here, okay? The reason this is different is we're not trying to figure out just X and Y by themselves, but we're trying to make them be equal, okay? So let's set this one up a little bit differently and let's go through and annotate what we know. So we've got Blue Label. There's a fee of $40 plus 6 per shirt, okay? It's $40. And there's $6 per shirt. Now when we see a unit right like this, $6 per shirt, that makes me think slope, okay? In this second company, Extreme Graphics, there's a $100 setup fee. And that is extreme. But they're only charging you $4 per shirt. Okay? So, we know just looking at this math, if we are not buying many shirts, maybe just a handful of shirts there, Blue Label is probably going to be more expensive. If we are getting a lot of shirts, like for the whole school, Extreme Graphics might be cheaper because we've got fewer per shirt. What I'm actually going to do is change this up a little bit, okay? I'm going to, instead of making an equation for Blue Label and Extreme in terms of X and Y, I'm going to let Y be the total cost for my order. And I'm going to let X be the number of shirts. Okay? So if we want to make an equation for Blue Label, what would that look like? Well, the total cost, Y, is going to be equal to $6 per shirt. That would be 6X plus a $40 setup fee. That 40 doesn't change no matter how many shirts we buy. For Extreme Graphics, we know the total cost for them would be $4 per shirt. That would be 4X plus the setup fee of $100. Okay? Now I've got a system of equations here that I could solve pretty easily. Think for a second. How would you choose to solve this system? If I'm looking at that, I'm probably thinking about graphing. And the reason I'm thinking about graphing is because it is in slope-intercept form to begin with. Now, I could probably do it by hand, but I'm probably going to hop on Desmos or my graphing calculator and graph these two systems here. Okay? Now, I say that, but let's solve this using the elimination method. Right? When we looked at the elimination method video, we said that we wanted them in standard form, but you can use elimination if we've got two things in slope-intercept as well. And it's nice because you've got Y and Y. Y minus Y gives you 0 equals 6X minus 4X is 2X. 40 minus 100 would be negative 60. So here this says 2X minus 60 equals 0. If we add 60 to both sides, then 60 equals 2X. Divide by 2 everywhere. And then 30 equals X. Now we said a minute ago that X was the number of shirts. So it costs the same when we get 30 shirts at each place. Don't want to write profanity. 30 shirts. Let's figure out how much that's going to cost at either company. So at Blue Label Graphics, that's going to be Y equals 6 times 30 plus $40. 6 times 30 is 180 plus 40 is $220. Okay? At Extreme Graphics, our total cost is going to be 4 times 30 plus $100. Well, we know 4 times 30 is 120 plus 100 would give us 220. Think for a second, if your club is buying more than 30 shirts, who are you going to go with? I think Extreme Graphics would be the way to go. And if you're buying fewer than 30 shirts, probably go with Blue Label. That won't bother you as much. The cheaper setup cost would be the way to go there, right? Guys, girls, if this video was helpful to you, I hope it was. Thank you for watching it. If you would like to see more instructional videos on math, specifically in Algebra 2, check out my channel, Old School Math. I'd be happy to help you with anything you're working on. Thanks for watching.